give you a quick. Give me 1 second. I'm just getting echo. Let me fix this. 1 second, guys. Yeah. So today, we are Nikhil with us. So today he'll be taking us on beyond the basics, tips and tricks for advanced TypeScript development. So he's a senior front-end developer, primarily working on Reactjs and TypeScript. He's an awesome speaker and writer. So he almost 4+ years of experience in the front-end domain. We welcome Nikhil. Thanks for your uh, speak today.
Yep. Thanks for
Yeah,
having me, guys.
it's all
Shall we
you.
start?
Yeah, let's
Okay,
get.
cool. Yep. Yeah. Thanks for joining, guys. And yeah, I know it's a Saturday morning, and thank you all for joining here. Um, so quick intro about myself. I'm a front-end developer. I've been working on front-end for almost 4 years now, and I use React. I also use TypeScript quite often, and um, so I used to use TypeScript since 2 years, but recently in the last 1 year, I've been using it extensively, creating more and more components. So we have a design system in our company. So all those design system, the component library has been used by multiple teams in the company. So we want that to be typed and more generic as possible, to so everyone else can use it for their own use cases. So that's when I started learning more advanced concepts of TypeScript. So and that's what I'm going to share with you all today. And before that, I would just wanted to get into some basics of TypeScript so that we can start with the advanced concept a little bit. So yeah, let me share my screen. Yeah, before even going that, so um, maybe you can post in the chat as well. If you are using TypeScript, what is the major reason for using TypeScript? So if you all guys can post your answer in the chat, that would be good. Because like it's easier to go with JavaScript, and that's pretty much most people do it. So any specific reason why you are guys are choosing TypeScript over JavaScript? Yeah, type safety. Yeah, that's pretty much what TypeScript does. So it's basically a tooling on top of JavaScript that provides types. Anyone else? Yeah, Angular recommends, right? Yes. So my reasoning would be one is, yeah, it provides new ECMA features, right? That's also one thing. So even when there is a proposal for adding some feature to JavaScript, TypeScript community might add that feature quicker, and they have it in their tooling that they can use. And once it can transpile to older version of JavaScript, so that way you don't have to worry about the browser support. That's something TypeScript is useful for. And yeah, generics, yeah, you can write generic components which are typed as well. So that's also we're gonna see in the talk. And so my reason would be it is very easy to refactor an older function if it is in TypeScript. So if basically TypeScript is type safe, and it catches your bugs in compile time, your type bugs in compile time. So when you do some refactoring and you're changing some function arguments, let's say you are changing, you have two function arguments in your existing code, and you want to change it to one, and you just save it, and you don't check where these functions are being used. So TypeScript will throw an error in those areas where it's being used, where it's being called with two arguments instead of one, and you would have a compiler error. So once you go there and fix it, then that error is resolved. So that's a basic example of refactoring. So if you want to change a code, TypeScript will throw an error on the usages of, if it's a misleading usage, then you can go and fix it quickly. That's a major thing for me. That's why I use TypeScript. And another thing is auto completion. So if you see here, right, the user is an object with name and age. So if I just type dot, right, it will show me what are all the options available. So yeah, let me. Okay, I think this is for. Okay. If I plus dot, right, what it will show me what are all the properties available in this user object. So this is okay because you can see it right away here. But if you're using some library, let's say you're using some component library like Material UI or and design, they have all the properties. Those components would have props, and those props would have some certain types. So if you are just using JavaScript and you don't have those autocomplete set up properly, then it won't show you what this component is required as props and all those things. So if you use TypeScript and imported the right type definitions, then that would show you what are the props you needed. And also, if the library has some comments, right, for each properties, that will also be shown here. What is this age is used for? What is this name is used for? So those things are really useful for me. I don't have to go back to the documentation and check it every time. I can just use this autocomplete feature and figure out what property I need to use in this particular context. So that these are two major things. And also your code is auto-documented when you use TypeScript. So let's say if you have a function and if you're calling that function, let's okay, yeah, I would get into that once I start the basic explanation. So first, let's start with some basic stuff before you go into the TypeScript concepts. So I have 8 advanced TypeScript concepts. First, we'll start with the basic. So, and one other major thing about TypeScript is you don't have to, learn it all at once and then implement it in your company or in your personal project. You can learn incrementally. So whatever works in JavaScript, TypeScript works in JavaScript. So it's just a superset of JavaScript. So if you have, you don't have to do any kind of types or anything to start with TypeScript. We don't have anything else. We just have this. This is just normal JavaScript, right? Still, if you hover over, you will see the types added to it. So you can incrementally migrate your existing JavaScript apps to your TypeScript without, without learning everything fully. So you can incrementally learn and adopt to TypeScript. That's one advantage, that you can just jump start with TypeScript. So I declared a user here with name and age property. So when I hover, this is the two properties that's being shown. So one advantage of TypeScript is, or any type languages, you can't modify the type of a property or a variable. So age is number, so I can't assign string to it. It will throw me an error. It will say string is not assignable to number. So this would avoid most of the bugs. So ideally, this variable, the properties, is not intended to have any other value other than numbers. So if you are, let's say, it's an age property, if you're having some calculation on top of it, let's say you're adding 2 ages, or if you are dividing 2 ages, then if it is a string, if there is a string, then that would cause a bug in your application. So instead of encountering that bug in the production, we can encounter it in the build time and then try to fix it. So that's also one of the use cases of TypeScript. So that is so the whatever I write here is part of JavaScript, so it's not type specific thing. So only the compiler that throws error is TypeScript, but everything else is part of JavaScript. So you can incrementally use TypeScript. All right. So now let's get into the some types and interfaces. So you can define the types in 2 different ways using type and interfaces. The difference is very minimal. So I would prefer to use interface if I have an object type. So this is an object. So if you want to type an user, I'll just use this interface type. But if you want to have a single variable, or it's not an object, let's say if you want to type a number, or let's say we have a type, and this can be either admin user1, and let's say there is another user2, and this user is uh, non-admin, let's say. Okay, we have these two types. Now this type is either admin or user, but if you hover over the user, now it will see the type is string, right? But I want the type to be either admin or non-admin. So for those cases, instead of interfaces, I would use type, because that's the only way. Type, and then let's say user type. User, instead of type, let's say a role. That would be app property name here. User role equal to either I want it to be admin or I want it to be non-admin. So now I would add this to the type or interface. Let's say I add it to here. I want this role to be user role, and I want this role to be user role. Okay. So now if I, let's say, use type and then type it here. All right. So this is how you type a variable. So this is the type definitions. These are all type definitions. If you want a variable to have this properties in this type definition, then you can assign it like this. So now I have name, age, and what else I have is I have a role. So these three are the properties that are allowed to have the user variable. So now this role, and I can't give any other values. So it will throw me, this is not assignable to the user role. So user role is either these two. So this is the pipe operation that defines either you can have admin or non-admin. And this will also be shown in the autocomplete. If you press control and space, you will have the autocomplete as well. So you can either have admin or non-admin. So you can't have anything else. Same goes for user too. Let's say this, for this I can use interface. Same thing, you can either have admin or non-admin, right? So for the single types, if it's not an object, I would use type property. Otherwise, I'll just use interface. There's not much difference between these two. All right. So now let's look at functions. Let's say, okay, let's log details. No worries. Okay. Let's return. Let's say return the user dot role. Let's say return the role. Okay. So now, most cases, TypeScript is so intelligent that it can infer types automatically. So let's, in this example, right, if I don't have the user, it would infer the types of the properties of the user. So name is string, based on the value that I give. I don't have to type it, it would infer. So in specific cases where you want to have restricted types, so this is called as restricted types. So instead of string, so role is basically string. Instead of string, I want the string to have only these two values, admin and non-admin. So in those cases, you can restrict it based on, you can type it. But if you don't want, if you have the basic data types of the JavaScript, right, the number, string, boolean, and all those things, the TypeScript would try to infer from the value that you give. So in those cases, see, the values are being input. Same way, if I have a function and I just type the parameter here, but I didn't type the return value. So I returned the user.role, but I didn't type it. So usually you type it like this. So if I want to return user role, I will give user role. So this is the function argument, this is a function name, and I'm going to return user role from the function. So now you'll see the definition you will see here. So you return is a function, and user is the parameter with the user type, and the return type is user role. But if I don't give this, TypeScript still infers it. I don't give the user role, but based on what I return, TypeScript will understand. So let's say I have a condition. If user.role, let's say user.age is less than 20. If it's less than 20, then I'm going to return null. I don't return anything. But if it's more than 20, I'm returning null. I'm sorry, I'm returning the role. So now the what TypeScript does is it infers. So there are two options you can return from. One is null, otherwise it returns the role. So TypeScript, it knows that I can either the function can return user role or null. So TypeScript is so powerful, it can infer from what the based on the code that you write. So it's so most people, what they do is TypeScript is they would think that TypeScript is adds more complexity to the code. They have to type it all the time. But most cases, TypeScript already infers from whatever you write. So it's very easy to start, and then it doesn't add too much code complexity to your code, right? So I think we covered little of basics. So let's start with the actual talk. So I'll start with type gods. So this you might encounter most of the time in your developing application. Uh, so first is basically it's checking for types. So if you have, in this scenario, we have multiple types for this role. Similar way, if you want to restrict something, or if you want to uh, what do you say, if you want to cut down row types, you can use type guard. So I have this function. Basically, it checks for if the type of the parameter is string or not. That's what it does. So ignore this for now. So just ignore this for now. Okay. So it's a string and it turns a Boolean object, right? Because it is inferred. So we have the equality operator, and this the function is in the TypeScript infers that this function returns a Boolean object. Okay. So I have this example function, and I'm checking for this. So if statement has Boolean expects a Boolean. So I'm calling this function with the argument that is part. So argument is any. So it can be any number, string, or anything. I just typed as any. So just for this example. And if it is just a string, then I can use these string properties. So length is part of a string property, so I can use that. So only if it's a string I can use it. If it's a number, I can't use a length property, right? So that's why I have this check. So I want to have some string operation inside this if statements. So if I don't have this, right, even though I have this check, right, string check, this doesn't provide me autocomplete. See, if I do foo.type, it doesn't provide me, because since this is any, right, TypeScript is not that intelligent, I would say. So it doesn't know, even if it is a string type, it doesn't, this variable is not considered as a string. So unless you type this, right, unless you explicitly type this, test is string. So this is a type guard. So whatever you're saying is you're telling the TypeScript what I'm checking for. You're checking for if the test, that is this variable, is string or not. That's what you're checking for. So now if you see, if you hover over, the type is test is string, right? So it's not Boolean anymore. So before that it was Boolean, because this is a Boolean check, it was Boolean. Now with this, it's not Boolean anymore. So now what happens is, whenever you call this, still it returns Boolean. The code returns Boolean. But since we have this test is string, now you have all the properties that the string has. So now this foo variable is not any anymore, because since it's inside this if statement, and this if statement is a function that has test is string. So basically this variable now is a string. TypeScript knows it's a string, right? Not only the runtime code, even the compile time code knows it's a string. So now if you see, all the string properties or string functions are available to you. All right. So this is one example where you can type guard your code, basically. So basically guards, in a sense, it guards you from other variables being used or misused in a way. So only if inside this function you be certain that this variable is a string, not any other type. Okay. Next idea of type guard is assertions. So here we are not throwing any errors. We are just checking for Boolean values. In the next step, we will throw the errors. So ignore this as usual for now. So here, what it does is it doesn't return anything. It's a void, but it checks for string. Same thing. If it's not a string, now I'm throwing an error. It's not a string, right? So this function throws an error if this parameter is not a string. So same thing, I'm calling this function, and I want to throw error if it is not a string, and only this function needs string. It only has string operation, let's say, and it would throw error if it's not a string, if you're not passing a string, right? So same thing, I have bar. So at runtime this would work definitely because we are throwing an error and we have only string, but we want that type. So TypeScript is all about code completion and you know type annotations, right? So if you have a lot of logic after this type assertion, then you want this to be a string, right? Because we know it's not a string, so it should be string with it. But here um, if you type dot and then a command space, it doesn't provide you all the string properties because but as a developer we know it's a string and we want all the string properties to be available here. So for that, one hack you can do is you can just say, once you come here, let's say const bar2 equal to bar, and then as string you can use this as property. So now what you'll do is you'll have this bar2. Now this bar2 is a string because you specifically explicitly annotated it. Now this would work, but ideally this shouldn't because this shouldn't happen because um, we don't have to manually type use as whatever the type is. So instead, what you can use is you can use the asserts. So this is we are doing test is string. Now we are asserting that is a string because we are throwing errors. We are doing the asserts keyword in the TypeScript. So now what it does is it knows we are throwing this error. It knows we are throwing error. So we are telling TypeScript we are throwing error. And then now, if you see, this is string, bar is string, and you have all the string operations. So this is how you assert a specific type, right? So this is about type guards. So if you have any questions, you can post in the chat or else unmute yourself and ask. So for now, I'll keep going and we can answer the questions later. So next we move on to conditionals. Okay. Okay, this is a React example. I hope people know about React and use it a little bit. So let's start with this. Okay, so this is a usual pattern. So we have some common properties, common props. Let's say, so I'll just explain what a component is. So we have an avatar component which has icon, source, name, and size property, and we are using this avatar component in a different component. Let's imagine this is a component in different page, and we are using this avatar component here. Okay, so we have common property, common props. So name is common, age is common, and size is common. So these are common properties, and this is the same thing that I did here. So I use type and have basically enumeration kind of types. So this variable the size variable can have only these properties, small, medium, and large. And it can also have undefined because this is optional. So this is how you define optional properties in TypeScript. So you use question mark before the colon to say this property is optional, right? And this is the conditional props that I have. Okay, so what I'm planning to do is this avatar component. Either it can have icon, you can provide your own icon. Icon would be a JavaScript component. You can provide an icon component, or you can provide a URL source, right? So for your icon, for your image to render. So avatar component, let's say avatar is like your user profile avatar icon. Either you can provide an icon yourself from wherever you're calling. So I'm calling the avatar from home. So you can either provide the icon itself, which is a React component, or you can provide just the URL, the image of URL of the other component that you can provide it, and it will render it. That's the idea here. So you can provide both. That's what we are gonna do. Learn how to do that. Either you can provide icon or source. You can't provide both. So for that fix, what you can do is you can have this conditionals. Same thing. We are using the pipe operator and doing it, but the only trick is you are making one as optional here. So here icon is optional, and the way you provide optional is either you provide undefined, but undefined would show you the icon as well. So there's one other type that you can use is never, which would never have the value. That's what it means. So you can have the type. You can give never to a prop or variable that would never exist. That's the meaning of it. So icon is never, and we have source. So this is how you provide comments in TypeScript. It's basically JS docs comments, so double star after the comment, and then each line would have the star, and it will end it here. So we are just saying this source is optional. So if you hover over source, you will have that comment that you write. Right. So you can use this for pretty much everything. This command is used for just for adding one helper text, or you can use some people use an example here as well. So how you can use this prop or all those things you can provide here, basically comments. And here the next object is icon is a React component that is all that is required. So icon is required, and source is never. Right. This is the conditional props. So now if I import avatar, and let's say I don't import. So if I don't import, then I will have an error because the name is required that I gave, but either icon or source is required that I didn't give. So if I hover over, you can see icon is required and source is required. Either one I can give, right? But here it defines both as required. So let us see. But see, when I give a source, right? Let's say this is a URL, and now if I hover, now the icon is optional. See, there is no required, the comment here, right? So icon is optional. So since we gave source, right, icon is optional. But if I give icon, let's say it's a React component, and now I give source. Now I check for source. Source doesn't have this required comment because it's optional. So that's how you conditionally render it, right? You can easily achieve this without having the conditions. So let's say you don't have this. Let's say you don't have this, right? And let's say you have everything here itself. We have icon also here, which is optional because basically if you give source, it's optional. You have source also. Now it's okay, but if you don't give anything, it won't throw error because the other component needs icon or source. Since we provide both as optional, this won't throw error, and that would cause your code to bug out because either source is icon is optional to render the image basically. Since you don't give it, this won't throw any errors. That's why condition is powerful. So you can't have both as optional. If you want to have either one as optional, then you would need to have this conditional props. And so basically I'm just using this AND operator. So this pipe operator is for OR. So the size is either of these values, and this AND operator is to basically intersection. It combines both the properties, both the types. So now this common prop is name and size, and this one is name and sorry, not common props, it's conditional props. Condition prop is either this one icon source or source icon. Now this avatar is combination of everything. It's name, size, and icon source. So now it will throw an error. It expects either one. Once I give any one, it will stop throwing error, and it would make the other as optional. I'm sorry. It would make the other as optional, right? Cool. This is about conditional props. And as usual, if you have any questions, post it in the comment on the chat. It's more the generics. Generics is the most useful advanced concept of TypeScript that I would say. So before going into that, let me just quickly tell you about how generic is defined. So generic is defined in two ways. So a type can be generic or a function can be generic. These two are the major things. So let's first think about types. Let's say I have an interface. What example I can give? Let me think. Okay, just I think we can just go over here itself because this is a good example. So I have this type. Imagine this can be an interface as well. So there is no big difference between those two. So I have a type. It's a props type, list props, call this list component. and I want this items to be generic. I don't want them to be of specific array. I want it to be an array, but the inside an array, what I want is generic. So the user of this component can provide anything, any kind of array. That's what I want. So how I define interface generic is using this angular brackets next to the type property here, and this whatever you can give. This name is your similar to a variable name, whatever you can give here, and you can use this inside your type definition. So I have this t item as a generic, and I'm using the t item as an array here. So t item can be an array of t items basically. So the items can be an array of t items. So t item can be anything. It can be a string, it can be an object, or anything, right? And this is the render item. This is a function, and I'm passing this generic to the function. That's what I'm doing. So think of this as a function itself. So normally, how you define a function? So if you define a function, this is a function, and it has an argument, and it has a return type. So yeah, it has a return type. Okay. And what you do is you use the arguments inside the function. So let's say you calculate arg1 plus 10. You do all these things, right? So imagine this is the same as this is similar to generics. So this, consider this as a function name. So it should have a name. Okay. Consider this as function. Function is the type here, and this is a name of the function here, name of the type, and this is the argument, and this is the generic. We are passing the argument like this, right? And this argument can be used inside the definition function. So here I'm using this argument, and here I'm using this generic in these two, right? So so basically, function is just an analogy to I'm just using it as an analogy for the generic definition. Okay. Okay. The same way you can call a function, right? How you call this name function? You call this name function by passing any value to it. And this 10 value would be assigned to the argument, and that will be passed to here as well, right? And if I return something arg1, it would be 10 plus 10 is 20. So that's what it will be. We can do calculations and everything. Same way, you can call this type using like this. So I'm just using it. So instead of this normal brackets, we are using angular brackets to call the type, right? So this is how you call the function. So call the generic type basically. So now this is the generic type definition, but in the functions, how you define generic is like this. Same way, this can be any name that you can give. I just gave us the item just to be consistent with this, and you define it after the function name, right? And basically, it can the function can this is a function function parameter brackets here, and I'm extracting these two properties from this object. So list properties has these two properties. List props type has these two properties, item and render. Basically, I'm extracting this and then using it here. So, and then whatever the list item that I pass, whatever generic that I get here, I'm passing it to the generic prop type. So this is the definition. This is the basically function calling. Think of it like that, right? So this is how you use generics. And so now this component is generic. So the idea of this is I have this generic item. So I want this list to be used in multiple places. So I want to define a list. Let's say it can be a horizontal list, and this only has some kind of container. Basically, it will have this arrow, and it can be scrolled through horizontally, basically, and have the operations. So clicking on the right should move to the right, and left should move to the right. Think of it like that. But all this code should be written here. I don't want to do this horizontal scroll code in other places, but I want to use this horizontal scroll in other places where I can. So the items inside this horizontal scroll can be different. It can be a string of scrollable. It can be a card of scrollable. It can be user list. It can be a it can be courses list and all those things. Anything, it can be anything else, right? So I want only the container to be generic, and I want the list component to be as generic as that. Any kind of items can be listed in a horizontal manner. That's what I want. So we don't know what the item structure would be. So what I'm exposing is I'm exposing items and I'm exposing render item. So I don't know how to render an item. I know I have to render. So I know the length of the item. So once they provide an item, I know the length, but I don't know what the properties are. So what I'm doing is I'm exposing the render item function itself. So you decide what to render, right? And then I'm looping through it, and all the CSS, all the scrollable logic will be here, but the actual item rendering would be in the calling component. So this list component is being called here. This is how it should be used, right? So I have these two properties, items and render item. Items is an array, right? Because I have defined it as an array. So it can't be anything else. It should be an array. And this can be anything. You can give string here because there is no restriction here because it's a generic. In this scenario, what I'm going is I'm providing ID as 1 and name as Nikhil. Basically, this is an array with array of objects with these two properties. Okay. Now the beauty here is once I have that property, right, this render item. Since these two are linked, right? So items and render item linked because of this T item generic. So if the T item generic has an array of object with ID and name, this T item, this item would also have the same object with ID and name, right? That's the beauty of it. So if I do item dot, then this would autocomplete. I can either have name and ID based on this. So if I have an age property, then I have age as well. So see how it's tied up, right? So you have this type definition as well, but this component is more generic. It can have any kind of property, any kind of property object names. It can be a string. It doesn't need to have an object. But once you define this render item is tied to it. So whenever you change it, this render item type also changes. So that's how the generic should be defined in a nutshell, right? It all happens because of the T item generic. So we are passing the T item. So we are not manually passing it. So this is how you usually call a component, right? There is no generic way of calling component. There is no generic here in this usage. There is generic in the definition, but there is no generic in the usage. So all the types are inferred from whatever the value that you pass here. So basically, this is T item, right? So I'm passing it here, and I'm passing it as items here. So whatever you pass here, that would be a generic, and that would be tied to the render item as well. So you don't have to manually pass any other type here. So that's why it's more powerful. So you can just define this one time, and in the usage, you don't have to think about types. You can use it in the normal JavaScript itself, JavaScript React component itself. You don't have to be TypeScript itself. So the usage is more simpler. Once you define generic and you did it once, then you can export it as a separate package itself. And once you import it, you don't have to think about types. You can just use it then as you normally would, right? So that's the power of generics. There are few other examples of generics as well, but
Hi, Nikhil.
yeah.
Sorry to interrupt. So there is one question in the Q&A. If you ask, access it or
Where?
otherwise, okay. There
Yeah.
is
Oh,
one
here, right? Okay,
Q&A.
okay.
Yeah.
Yeah. If we declare a function return type as string, can we reassign it to a string literal variable? Okay. What do you mean by that? I don't clearly get this. Reassign it as a string. So I think you meant this one, right? So for example, I have a function. And string. Okay. So let's say name, right? It has user. User type and it returns name. Okay, now it returns a string, right? So you meant, so string literals are this ones. So these are all string literals because it's a string, but it can't have any other values. It can have either admin or non-admin. It's a literal value basically. So you want this to be a literal value. So one thing I would suggest is there's one concept that you can do. So let's say you have list of names or list of it's a list of types. Okay. This is admin type. This is a user type. This is a student type. Okay, list of students. Now this is a string array because it's a string array. But let's say that these types are going to be constant. It won't change. The types can be either of these three. Then what you can do is you can do it as const. Now if you hover over, the type is read only. You can't modify it, but it can't be any other values also. Can be we modified the string array as a literal. So admin, user, and student. So it can't change. So now what you can do is you can there's one quick trick. You can infer types out of it. See, GitHub Copilot automatically auto completes. So now if you see, I'm using type of. Okay, type of this types array, and then this is the key part. We have to provide what you are expecting. So array is a number, right? So index all the index in array are numbers. So I'm providing number here. This is just the TypeScript syntax. It's not the normal variable or anything like that. So I provide this. Now what I get is I get these literals. I get these types as literals. So based on the array values, I extracted the types out of them. So you can define basically roles in this way. You can use a roles array in your code, and if you want to type it, then you can use this type of, and then provide this number in the brackets, and now you get types. So this is string literal. So we have string array, and we make it as const, and it's readable. It's read only, and it can't have any other values. Now I convert them to string literal types. So this is one way you can do it. I think that's what we meant. If it's not, maybe you can post another question, follow-up question on this. Okay. Okay, so this is about generic components. Now this is also generic. Okay, this is also generic. It's a state machine example. So I hope people know about state machines. Okay. Yeah, cool. I think there's one other question also in the chat. Okay, here's a generic item list example. We are not defining any type, and it's being inferred based on the props we sent, right? You can do some same thing with JS function, right? What makes it script message? Yeah, so you can pass the same thing. So if you don't have types, right? If you don't have generics, you can do anything with it, but you won't have the type definitions out of it. So when the people are using it, let's say we don't have types. So let's say we don't have this, and we don't have this also, right? We have just this. It's just this component with these two properties, and we are rendering it. So now we don't even know what. So if you are a user, right, you have this component, you are importing it from the library, and you are using it in your function, in your component, but you don't know what to pass here. It can be any. See, so you have to go and check the documentation, or if you want, you have to explore more. You have to see the examples and all those things. You have to try it yourself. So from the naming of it, I know it's an array. Okay, it's an array. So I can just define ID1 name maker. Okay. Now I have this render item also. Okay. I'm not sure if it is a function or not. Okay, let's assume it's a function. Okay. Now I get what would be the callback function that I get? What would be the argument of the callback function? That I don't know. So let's say I have an item also. Now what the item would be? That also I don't know. So these are unknowns. You have to document them on your own if you are using just JavaScript, or you have to provide multiple examples to how to use your components. So it's good if you are if you are a big project and if you are a maintainer of a project specifically, then you can provide some more support to it. But let's say it's a common component that it's used with throughout your company, and you don't have much human resources to dedicate a particular person to maintain the component, then it will be too difficult. People don't know who to ask for, and and all those usage of the component basically. So for those things, TypeScript is awesome, right? So once you provide a generics, it's not that difficult. Like once you get the mind mapping, right? So what I will use is I use this analogy, function analogy. So I will think of it as a function and use this generic as a function argument, and then the return type as well, basically. So once I have this analogy right, then I can just use this couple of line codes, right? This extra code to make this component much more easy to use from the user's perspective. So you know what to use. You are the developer of this component. You know what to use. From the user perspective, let's say it's a different team using it, then you don't know what to do. Like the team don't know what to do. So for those things, just for ease of use and what to expect for the component, what the component would be rendered, what is the callback function that is being get, all those things. For those things, types are really useful because people when they use it, they usually don't go to the source code of the component and see how it is being used, right? That's why this is very powerful. I hope it answers. Okay. Okay. So state machines is um, basically it's a programming concept where you define multiple states as an object or anything, and then there will be an initial state, there will be end state. So basically, the initial states and the end state would can only be whatever the state that you define. So if you define A and D, the initial can be either A or D. It can't be C or anything else because there is no state to go to or start with, right? So that's the powerful of state machine. So basically, if you are defining a state machine, it has to be typed because you can't give multiple values or different values to states that is not already exist. So you want that to be typed. So how do you type this? Same way, you have to go with generic because the state that the user can define is anything. You can't know what the user will define, but you have to know the initial value should be either of the states that they define, right? So that's why you go for generics. Same way. So the last example, I use the type. So this one I'm using interface. That's the only difference. And again, I use the function keyword to declare the function here. Now I'm using this const arrow function syntax. Okay. The same way. So the only difference, maybe I can just do side by side here. Yeah, the only difference is in the functions, you have to define a generic after this. Here you have to do it after the equal to sign, right? And interface is common, so there's no difference here. So what I'm doing is I have these two function arguments. I mean, there is one argument with it's an object basically with two properties, initial and state. And how I'm defining the config is the initial would be the key of the states, right? So key of is a TypeScript thing. So same way, let's say if user, right? So I have this user. Okay, type right key user equal to key of user type. Okay, so now this one would have okay, it's not showing up. So what I'll do is I'll just type it. Okay. Okay. So now key will be a string. So key of this user type. So user type is name. This is a user type. What it has three properties. It has three keys basically: name, age, and role. So now when you use key of and then have a type, right, and then you use it as a variable. Now the only options that you can give is age, name, and role. You can't give anything else because those are the keys of the user. That's what this variable is restricted to, right? So the same way you can use this key of property in this manner because we want the initial property to be either of these keys. It should be either A or D. It can't be anything else, right? So it should be either A or D. So if I give R or something, then it should throw an error. Expected is only of these properties, right? So you can use this key of thing to type the initial values. So I provide the state here, and that state is typed to this state. So this is the generic, and this initial is based on this state type. It should be key of this object basically, right? So now when I use it, I define the same thing. I pass the generic here and I pass it to the config property. Same way how you call a function, right? And then once you use it, once you call this function, see how the autocomplete is. So let's say I'm just creating a new function. Now I just press Control Tab. and I know what are the properties that I should be sending. I know it's an initial, so okay. Now if you see, there is nothing else provided, right? I don't know what to send because there is no states defined. Okay. Now once I define the states, right? I define the states. Once I define the state, now it say it can't be empty. Okay. So what should I give? Press Control Tab again. Then I know, okay, these two are the only options that I can give because it's based on the state. Now I know. So the ease of use, right? How easily it can be used and how easily it can avoid bugs. So if you don't have types, then if you type by mistake, if you type T, then you won't get compile time errors. Then once your code is deployed, then okay, then only you can know, okay, you can't start with the type initial state as T because there's no state T itself in the definition. So that's how TypeScript is helpful. Why do I have a second example? Yeah, so I have a second example because of this variation. I use the function variation instead of this arrow function. So yeah, this is how you use generics. Okay. Any questions? Okay. I don't know whether it's only for me or anyone. Your voice is breaking. Okay. How is my voice now? Is it audible?
Yes, Nikhil, good for us.
Yeah, it's good.
Okay, good. All right. So yeah. Okay. Any other questions? Like post it in the comments. Okay. Next, go to use state. Okay. Let's remove this. This is also a generic example. Because I love generic, so I have 3 examples on it. Okay. So most probably you would have used use state from React at some point of your life. So let's see how use state works, right? So let's see. So cons. Okay, let's use state React.use state to be specific. Okay. Okay. What it provides. So React.use state, what it provides is it provides. You can also see if I hover over, you can see. Now it's undefined because I don't have any values. Let's say I provide empty string. Now obviously, it expects an initial state that is a string that I gave it as string here, and then so React also has this initial state defining initial state as a function. So you can provide initial state as a variable like this, or a value like this, or it can be a function also. So once you call the function, you will have the initial value being set. So that's also another way. And what it returns, this is the important thing. It returns an array, basically a tuple. Basically, if it's only 2 or fixed amount of array, it's a tuple, and it returns a string based on the initial state. If it is a number, okay, basically it returns 2 things. One is the initial state, one is the state itself, state variable, and a function. Basically, dispatch React function to change the state. That's what it returns. Only 2 things, right? And this one depends on whatever you pass. So if you pass 10, then the return value is number. It's not string anymore. If you pass an object, let's say if you pass a boolean, let's say it's boolean. If you pass a boolean, then the return value is boolean, right? So use state basically infers from whatever you provide as an initial value. Same way, I want to replicate the use state behavior. Okay. There's also one more thing use state does. Okay, let's think about it later. First, I will see how I can replicate it. Okay. So use state, right? Use state is a function. That should be generic. Yeah, because we know that there's only one way to infer types based on the value that you give. So here also we did the same thing. We have the value, we gave the initial value, and this initial we gave the states, and this initial value is inferred from the states that you give. So we use generics. Same way, in the generic component, we gave the initial set of items, and this render item is inferred from whatever you give. If you give us age, then this would have an age. If you give if you don't have age, then where am I using it? Then this won't have an age. So basically, to do this, we have to go with generics. So I have defined a generic, right? Any variable, I just give T. Now this so where it is based on. So this the generic is based on the initial state. So here the generic is based on the states. So I gave the generic to a state, and then I use this key of to infer from it. And here in the generic component, I know the types is the initial generic. So I gave the type, the initial generic to the types, and then this one is inferred from it. Same way here, I want to give the initial to the state, and what should be the return type? This is how you define the return type, right? It should be two values. One is the initial state itself, the type of the initial state itself, and then the setter function, basically the updater function, right? So that would also have a that would also take a value, right? So you will pass an update value to it. That would also be the same type of the initial state. And what it runs, it doesn't return anything. So it's a void. So basically, it's a function. This is how you define a function. So in as a type. So it arguments is the type as t because that's what the initial state is, and you don't return anything, so it return void. And this is just simple logic, so you don't have to think about the logic much more. The only thing is it has an updater function, which is of this format. The argument with the type t, and this is what we return. So we return the initial state. That's what we return initially, and then the updater function, right? So I think this should be state, not initial state, because we have to return the updated state. So ignore the logic, but this is how the definition is, right? So now what I can give is I don't give any value. Okay, that's also one issue. So yeah, initial state can be empty, right? We have seen it here. Where is it? Here? No. Sorry, why is it throwing error? Okay, just a minute. Why is it throwing error? Okay, ignore this. Fine. I think here, right? So yeah, initial value can be empty. So if you state, okay, so initial value can be empty, then it's undefined, and this is also undefined. So initial value can be empty. You can give empty initial value to the state. So how can we achieve this? We can just provide this, right? We can just have the what is this? This argument as an optional argument. This is how you provide optional arguments in TypeScript, or I think mostly other thing as well. So you can provide this. So now this would be undefined. Unknown. That's interesting. Okay. But yeah, so I'll get into it. So let's say you don't have this, and if you provide string, right? Now the value will be string, and this will be a set string method. And if it's a 10, it's a number. Then this would be number, and this will be number. So we achieve this based on this. So now we have to achieve the empty values also, right? So one way is doing this. The other way is using the function overloading. That's pretty much is a concept in JavaScript also and other programming languages. But here the function overloading is pretty different. So we use it for only for the types here, right? So what I will do is I will just do this part. Okay, this part is same. This part is same as what we have here. So initial state t and returns t, and new state. This is same. This is the initial function definition. See, I don't have any return type, any function definition here. It's just the definition of the function. It doesn't have the function body basically. It has a variable definition and it has a return type definition. Okay, there's one other thing also. So as I mentioned, it also can have undefined values, right? So I'm setting the t as undefined here. So this is generic, and I'm setting it as undefined by default, and I have this as optional here, right? And then once it is optional, what will be the return value? It can be either whatever you provide here. If you provide, that will be a return value, or it will be undefined. And setter cannot be undefined because you have to pass a value to it, the setter function. So with these two, now I can provide empty values. Now this would be typed correctly. This would be undefined. Earlier it was unknown. Why is unknown? Why was it unknown? Because I made it as empty. I can also do this. or undefined, or same way, I can just define this, right? So I can do this as undefined, okay, and undefined, and make this as optional. I can do this. Now this would be undefined. But the one other catch is, if I pass 10 to it, right? Now if you see, this is number or undefined. That should not happen, right? Because once we are passing it, this can't be undefined. We can't make it as undefined because it's a number type. That's what React also does. So in the conditional props, now it's undefined because we don't pass any values. But once you pass it, this can't be undefined because it's a number type. It can't be undefined. But in our example, it makes it as undefined because we are definitely making this undefined. There's only one definition here, only one function definition here, basically declaration here with the type, and we are making this as either the type that you pass or undefined. So that would be return value. We can't do anything about it. So to avoid that, to avoid this undefined value, once you pass the valid value here, you have to overload the function. Basically, this is two different types of definitions. One, it either can be a value itself, right? We can provide a value itself, or we don't provide the value. It's not both. So that's why you have this extra definition here. This is the basic definition with the value being passed, and this is the basic definition where the value won't be passed. So these two are the values. So what TypeScript does is it will look for it will infer from what you pass, and then it will choose which definition to apply for. The function has two definitions, but TypeScript chooses only one based on how you use it. So now the number, the string, the value once you pass is whatever you pass is passed here. It won't be number or undefined. And once you remove it, it would be undefined. There's one other way also to pass the types like this. Now you type the state as string, but you didn't pass any value. Now what would be this? This would be string or undefined, because the initial value is undefined. You don't pass anything, but you type the useState function as string. So now no, only the values that you can set are undefined because it's empty, or the string value. That's what you type here. That also works in our case as well because it's generic, right? Either way, so the TypeScript infers from what you pass, or one you can explicitly pass what you need, like this. So this would match this useState. You're using useState, this would match this. Basically, function call. Think of it, the analogy function call analogy, right? We are passing this to this. Now this would be string or undefined, and this would be setter function. Okay. Cool. So this is how you replicate the useState behavior, if it's really useful or not. So I just use this to explain about these two types. They basically function overloading concept, where you provide two different versions of the function definition for two different use cases, basically. So from what I would do in this scenario is I didn't think of this myself. So what I did is I just gone through the code that TypeScript uses. So I just press command and then plus here and go to the actual definition of how it's being used. So I just looked into it and understand it, and then try to replicate it. So if most of the libraries that you use has types. So React has types. If you're using some component library and design or anything else, it has types. If you're using Next.js, it has an awesome type definitions. So you can go into their code base and check how the types are being used if you want to explore more. Okay. Do we have any questions? I don't think so. Okay. If you have any questions, post it in the chat. Yeah, I think we have another 20 minutes, so I'll go through these two examples. Okay. So now we defined our own types, right? So we defined our own generic properties. But TypeScript also provided its own, utility types, I would say. So let's say you have this to-do type. It has title, description, and completed. Now, do you want to do a type from this, which is only a preview type, basically? So what it does is it doesn't have it. We don't need this description type in this the new type that you want to create. So what you can do is you can pick the type from it. So pick is basically a TypeScript provides this utility function, utility type basically, and you can inside the Angular bracket, you can first argument is you provide the what from where you want to pick the type. So I want to pick it from to do. And what are the types I want to pick? So I want to pick title and I want to pick completed. These two are the only ones I want in my new type. So if you hover over this, that's what I get. I get type, title and completed from this to do, right? So this is very much useful when you want to do this kind of scenario. So you have a to do type and you have a preview to do. The preview to do is using different component and to do is using different component. So instead of defining this again in the preview, again defining type and description, title and description, you can just use the pick and pick the whatever the properties that you want. So the other one is omit. So this is just the opposite. So here you are picking it, here you're omitting the type. So in this scenario, it's omit is really useful because you want to omit only one value, one property. So you give the to do and you give the description that you want to omit. So this is the key I want to omit. Now if you see that is omitted. So title and completed are the only ones here. Description is not there. Okay. And yeah, so you can set the type here and you only have these two values. You won't have the description here, right? Another utility type is partial. So this is really useful. So you have this type setup to do. Let's say this to do, you have it in two places. One, you have it in your component. You know these properties are available to you. So once you have this to do value, these properties are exactly available to you. But let's say this to do is coming from an API. So in that case, these properties can be empty, right? Because you don't know what the API will send. It can be empty. It can send completed as null also sometimes. So you don't know. So you want to make every property as optional. So you have to do everything like this, right? You have to do it like this. You want to do it like this because you don't know what is required and what is optional, right? So for those things, you can provide the partial. So what it is, it make all the properties optional basically. So if you pass the type to it, and here if you hover, everything will be set to option. So it can be either string or undefined, string or undefined, string or boolean or undefined. So basically, it will provide the optional keys to it. This is really useful in that scenario I mentioned, right? The API calls, you are getting it from the API, then you don't know what properties can be undefined or empty. And one other example is to update function. So usually you would have the put operation in your code, basically in your form, submitting a form or something. So you have an actual to-do object which has all these things, and only you are editing the title, right? So you are not editing description or completed. You only editing the title. So the updated value can be only title, can be only description, or everything else. So it can be optional, right? Title can be optional. You are only editing description, then title and completed would be optional, right? So for those things also you can use the partial type. So here this can be partial. So it can be either the title or description. This to do would be everything else because that is the main actual object that you can combine them together and update it to do, right? So and once you update it, it would be everything because you are updating from the to do. So this way you can split up the different types and use it. Basically, you don't have to repeatedly create the same types. You can use the single source type and then create basically derive types out of it. So you are deriving the preview type based on the omit and pick, and you are deriving the partial type based on the partial. And that's pretty much it. And yeah, this is also one more thing. These are two lesser known utility types. This most probably people would have seen this partial and all those things. So here, if you want to check the return type of a function or the parameter of a function, TypeScript provides this also. So you have this function. So okay, one other thing is this is a function. This is basically a value, and this is also a value, right? So if you want to use this utility types works on types only. So this is utility type, and whatever you can pass is a type. It can't be a value. So you can't pass this small to do here. You have to pass a type to it. But if you want to find the argument types, or if you want to find the return types of this function is a value. It's not a type. So how you do it? You make it as a type. So you can use type of and the function name. So that would provide a type to it. So if I do this, function type. Okay. Now, if you hover over, this is a function type. It's function type definition, not a value itself. So if you see, this has to do, and that's a type, and the updated field, that's a type, and it returns it as a return type. So this is now a type. Now I'm passing this type to the parameters. Okay. Now what it does is, as the name suggests, it would give me what the type of parameter is. So if I hover over this, then this would be, it's an array basically. Parameters are arrays, right? We can have multiple values, multiple parameters. So this would give me an array with currently 2 values, because the update to do has 2 values, to do and updated to do, right? And with the types also, that's what it gives. Same thing goes for the return type. So I'm passing the function type, and what I'm getting is this to do JSON, basically title, description, computer. That's what's being returned here. You're returning to do, that to do is of title, description, computer, and that's what you get. So if you want, you can use these two. If you have the use cases, you can use these two utility types in your code. And there are a lot of other utility types. You can Google. There are multiple other things. So you can use utility types here, and yeah, there are a lot of things. Awaited, partial. That's what we talked about. Required. So if it's a partial one, you can make it as required using this. So if you have the partial, then make it required using the required one. And read only. So you can make an object read only. So, but this won't affect the runtime. That's what I'm going to say. Only that compile time checks would be done. So even if you save it, and then if you somehow bypass the compile time and then run it, this won't be read only. It can be modified. So just for your code, basically how you develop, right? That's what it's being used for. And record, yeah, this is pick. We saw pick, omit. Yeah, there are a lot of other types that they can explore, utility types that they can explore, right? So yeah, let's go over this one. This is really interesting. Okay, so I have this status color, okay, and I defined this constant. I explained, right? So you can define the array as cons, and this would be the literals. So this array can't be anything else. It can be only admin, user, or student, and you can define the types out of it. So this is how you define it, right? So you can define the literals out of it. Same way I'm doing this here. Where is it? Apparent text. Yeah. Same way I'm doing this. So I have this array status colors, and I have this prop type with the label and the color. Imagine this only for now. Ignore this for now. Okay, let's just ignore this for now. I just have this. So now the color would be either of green, red, yellow, or blue, right? So I have this tag component which renders the label with the color that you pass here, right? You can pass either of the three, 4 colors, right? So if I use the tag here in the home component, so I give the name label, and then I have these 3 colors, right? Cool. This works perfectly fine. So, but I want the tag component for the user to provide other colors also, other than these 3 colors. So these are the 3 preset colors that I have. But if the user wants their own custom color code, right? Hash the color code, they can give that also. That's what I want. How do I achieve that? So if I just provide string, right? Because color code is a string, so color codes would be like this, right? Hash and then f. This is the color code. I think 6Fs. Yeah, this is the color code. I can provide this. I can make this a string, right? I can make this string. Now I can give the color codes as f. But I lose the autocomplete for the status colors. So I want this presets also. I want these presets also. Apart from this, I want the ability to. I want the user to have the ability to provide this color code also. How do I do that? Yeah. So now if I give the hash code, right, this won't work. This will throw error because the color can be either this value. So how do I do that? So I do this using this, right? This is really interesting for me. So what I'm doing is this pipe operator, it can be used to provide optional, the or types. So it can be either green or whatever you provide here, right? So what I'm doing is, so this is just a string. I use a string literal, but this is the name. If I go Nikhil, right? So what you see here is it can be either blue, green, red, yellow, these things, or nickel. That's what I give, right? So, but what I want to provide here is I want this string, the whatever I provide here, to start with a hash, right? And then it can be anything else. It can be string, and this one is just for restricting the type. So it can't be any other string. It can be hash string, right? So that's what this one is. So now if I provide here, I can only see blue, green, red, yellow. But if I provide hash and fff, it should work. It would work. It won't throw any errors because the string that you give starts with the hash. So I can restrict the string that I pass with the hash. So you can't pass any other string to it. Only it should start with string. So if I pass this, it will throw error. It's not type of this, right? So this is really awesome that I encountered. So I follow this guy on Twitter. I think his name is Matt. Yeah, Matt Pocock. So he gives all these awesome TypeScript tips. So that's how I learned most of things from him. So this is really interesting, right? So you have this presets that you want the user to give, but you want to have the user to ability to give other types also. So they don't know what to give. They only know this one. So what you can do is you can use the type comments, right? You can use the type comments to give. You can also give color codes. Okay. So now if you hover over, you can see the comment that you pass. So user will know, okay, this is the expected value, but you can also give your different values, right? So that's about apparent types. This is apparent types. I'm not sure this is the exact term for it, but that's what I found from him on the internet. So that's how I named this. So yeah, that's apparent types. Okay. Do we have any questions on this? Okay. I don't see any questions, but okay. I think we have some time. I can go over this infer keyword. This would be little more advanced, but try to understand this. It doesn't have to be. You just understand it. Don't try to think it, because I'm not. If you give me if you ask me to write it on my own, I won't be probably doing it. But I understand what it does, so that's what the goal is here. So I showed you these types, utility types, right? So parameter, return type, and partial. These things, how they work is because of this infer only. So under the hood, they use this infer keyword to make this stuff happen. So I'm passing the function here, and this is inferring the parameters and then returning it here. Same way, this return type is inferring the return values and then returning the type here. So that's what this infer keyword is so powerful. So try to understand this. So we have this describe person, and this is an object. It has one parameter. Basically, it's an object with name, age, and hobbies. Right. These are all primitive types, string and number. But this one is a tuple. It has only an array with two values, both are strings. That's what it is, right? And this returns a string, basically. So the problem is, let's say if I don't have this. Okay. Let's comment this out, and okay. If I don't have this, right, I just create a person, okay, with a name with the same property as this. So it is a name, age, and hobbies. So I create name with a string, okay, and age is a number, okay, and hobbies is two strings, okay, walking and cooking. Now if you pass this to a function, this describe function, see what it does. It says string array is not assignable to two strings. It thinks this as a string array, which it is, but it has only two values. What it's saying is I can't assign this to a this is a string array. I can't assign this to a string array with two strings. So for just throwing error. So I won't be able to use. One quick way to do it is you can use this as, you can type annotate like this, string and string, right? Now what it does, okay, I'm explicitly doing it as two strings. So now it won't throw any errors because it is expecting two strings and I'm giving two strings. So now it won't throw error. So, but one other way to do it is, I think as cons also works. I don't think this works. Oh yeah, this also is not working, right? Because as cons, what it does is it gives exactly these two values, but this is expecting string values, not walking and cooking values, right? So this also won't work. So only way is as this string, two strings. But another way to do it is, so you can do this like this. But what if we don't know the so here there is describe function is here. So you can see, okay, this expects two strings, then you can provide as cons two strings, as two strings basically. But you don't know what this function is expecting. You only know the name of the function. You don't know what the argument is, another thing. So what you will do is, in that case, one way is you can provide the utility types basically. You can provide the parameters type, parameters, and get the function parameters. So we are going to see how this parameters is being implemented, right? So go to what is it? Infer. Yeah, basically it is using infer. So what I'm doing, I'm creating a type to get the parameters of this function, right? So I'm defining a generic. So I have a t, which is basically that type that I'm going to pass. Basically this one. So I'm going to pass the function type basically. So I'm passing, that's a t here, and this n, which is the arguments. So I want to pass which argument I need, right? So I want to return the first argument, I want to return the third argument, and all those things. So in this case scenario, I'm going to return the first argument. I want to get the type of the first argument. That's what this number is, and equals to, and t extends. So okay, this one. So this is how you restrict the generic. So t is generic, so you can provide anything, right? You can provide string, you can provide number, because it's generic. It can be anything. But I want this argument type, this t, to be a function type, because that's what I'm going to pass. I'm going to pass the type of the function. So I want this t to be restricted to the function definition, right? So that's what this extends keyword is. Extends restricts your types, generic type basically. So your generic type should be of this this type basically. So this extends, what I'm doing is I'm having this function. So think of it like just the one thing, right? So think of it, this entire thing as this. It's just a function. Think of it like this. It's just a function with multiple arguments, any number of arguments, and it's just a function with return type, any return type, right? This is this, but what I'm adding is I'm adding this infer keyword. So I have these arguments, I have it here. What I'm doing is I'm inferring the argument. So infer keyword, I'm inferring the arguments and then saving the inferred value in the u type basically. So I'm inferring all the arguments and getting the value saved in the u, and then I'm returning any, right? If I don't have any type. So let's say this argument doesn't exist, right? Now what I'm doing is I'm returning the number of what's being passed. So if I pass 0, I return the 0th argument type. If I pass 3, I return the third argument type. If I don't have that,
I
I return none.
sorry to
Yep.
interrupt. We are on
Yep.
time, but you can quickly wrap it up.
Yep. Sure.
Because we need to go for QA as well.
Cool. Yeah, I'll just wrap it up in 2 minutes. So that's what this does. So what it does is I'm extending, restricting this t to the type of the function itself, and I'm inferring the arguments and saving the argument as u, and then returning based on the number that I pass. And so if I plus 0, then I return the first argument. So that's what I need, right? The first argument is this one. So this basically is an object, and it has the entire object to it. So there is only one argument. So I want to get the 0th argument, and then get the type argument. So now if I return, now this has the entire structure of the first argument: name, age, and hobbies, which is string. So now what I'll do is I'll just assign this to this. I'll assign to this. So now what happens? Now string is now we are assigning explicitly assigning the type. So now this one would be considered as string, not as string array. That's what it does. Same thing goes for return type also. So we have seen this utility type return. This return the return type. So how it is being implemented is like this. So same thing. The T extends the array, right? Object, the function definition, because I want to only provide the function to the return type, right? To get the return type of the function. So this extends anything, but I don't infer anything. See, I infer the return type here, but I don't infer anything here. I infer it in the right hand side. So because I'm restricting the type here, and here is what I'm inferring. So I don't. So earlier I inferred the argument because that's what I want. I wanted first argument. So I inferred the arguments. So I infer you, right? This time I don't care about arguments. I care about only the return type. So I infer the return type. So I infer R. If it is inferred, then return the inferred value. If it doesn't have the return type itself, then return never, right? So now in this example, it has a return type of string, right? So now I hover over this return type of string because I'm passing this function to it, and it returns a string template. So that's what it does. So basically, what I did was I explored what this utility type does. So it turns out it's using this infer keyword to infer all the based on whatever you need. So here I needed arguments, I inferred the arguments. Here I needed return types, I infer return types. So that's what it is. So you can explore more about this. Even if you click this, you can see the how it's being returned, right? So we can explore more about this once you see. Think of it like once you start learning it, don't think of it like you have to know all these things. You have to understand all these things. That's what is the major thing. So you can check it out later. So yep, that's pretty much from me. Can I have any questions?
Yeah, Nikhil. Yeah, sorry for you to hard stop. It was nice session, but
Yeah, no.
however, it's for people. Shared with me.
Cool.
Okay, guys. Yeah, please go ahead with your questions if you have something to get clarified.
Not
Okay.
only specific to TypeScript. Any questions on JavaScript, React, anything else you can post.
Yeah. So one thing, guys, I just put that Nikhil Twitter handle in the chat. So like, please you guys follow him for like he used to speak like a lot of events. So you guys can follow him, and also you guys can to reach out to him even after the session. So if you guys need something. Okay, then if no questions means okay, I have need few minutes, guys. So since we started the session directly, I see a lot of guys newly joined today's session. So I just gave a very quick overview about our meetup group. So me, Dinesh, and Karthikeyan, almost 4 years before we started this group, we are primarily focusing on front-end, but not restricted to any of the frameworks. Like we have done the session for uh, Angular, React, the Bootstrap, plain HTML, all the core thing, right? CSS, JavaScript, and even that hybrid mobile development, Ionic, those things. So like we are everything open for the topics. Like everything runs in the browser, right? So front end thing, and we are community-driven group. We do. We have our sponsors and we have our volunteers and we have our speakers, right? So we just have a platform to just bring together all those folks and have some high quality events, right? So monthly meetups. So like the first thing, if you guys are interested to speak, so we are really happy to host you guys. So we have the form, if you go to meetup our profile, right? So we have the speaker proposal form. So kindly use it, and if you are interested, just fill up the form, send us a note, then we will just follow with you guys and host you in the next sessions. And the second topic, like we are also welcoming the volunteers, because like uh, we have some limited volunteers, so with that we are managing, so it will be really helpful that we get few more volunteers. So volunteers, like there are also form, like you guys can just reach out, or in the meetup you guys can directly reach out to the meetup organizers. So we'll as soon as possible we will get back to you, and uh, during that each planned meetup, right? So that time we will just discuss together, and uh, we'll just plan the work ourselves and make it happen, guys. So that's all I have to do. Karthikeyan, you would like to add anything? So Karthikeyan is the one of the co-organizer, guys, and Dinesh also here. So you guys would like to add anything?
Ramesh, I think I'm good. Just to extend my
Okay.
heartfelt thanks to the speaker and participant who able to make it today on a Saturday morning. Thanks everyone. Thanks for joining us. Hope you all learned today something. Hoping to host you in upcoming months as well. Happy weekend.
Thanks, guys.
You can, guys.
Bye.
So like, yeah, guys, please fill that the raffle thing. Like, okay, there's one question, Nikhil, in the chat
Hmm.
from Shanmugam. So you can
Yeah.
quickly address it, then we can wind up.
Yeah. In the first argument type example, okay. Here we are conditionally checking against any. If infer success, then any will be returned. What if infer fails? Then there will be no. Yeah, there will never be returned. That's what I had in the example, right? So yeah, you also have this never, right? So that will be returned. So which means it doesn't satisfy the condition. So this shouldn't occur. That's what it is. It meant. So even never we use it in the conditions if you remember here, right? Let me quickly share. So we use never here as well in the conditional props, right? So this basically means never basically means this scenario won't happen. That's what it meant. Just to end the third conditional, right? So we have this third condition. So ternary is two conditions, right? We have the condition, we have the return type, and what is the alternate return? What if it's not if it fails, right? So that condition we have to satisfy it. We can't leave it as empty. We can't just type colon and leave it as empty, right? So for that thing we return the never keyword. So it means this scenario doesn't happen. Hope it answers. Okay, cool.
Okay.
All right.
Then
Thanks,
I
guys.
think no more questions. Yeah. Thanks a lot, Nikhil, for joining today. Thank you, guys. We'll
Yeah,
see you
thank you.
next month with another great topic. Have a happy
Cool.
weekend, guys. See you
You too, guys.
soon.
Bye bye.